Okay, in this problem, they want us to find the volume of a right circular cone with a height of 20 and a base radius of 5. And they want us to use integration because I'm sure there's some equation out there that I don't know that you can use, all right? But we're going to use integration. So let's see, how are we going to do this? Well, I drew on the xy axis it's a cross section of a cone, right? Kind of a quarter cone, and it has a height of 20 and a radius of 5. Because think about this, if you're rotating this thing around the x-axis, you're going to get a cone, right? It's like a sugar cone. If you get the sugar cone, you get ice cream, it's got the pointy bottom, right? It's going to look like a sugar cone rotating around that x-axis. And the base radius, the bottom of the round part of the cone, the radius is 5, and the cone is, how high is it? It's 20. Ooh, it's a big cone. It's 20, I don't know, 20 inches, whatever, right? Okay, so we want to find the volume. So how do we find the volume of this cone? Well, I think what we could do is we could think of this as a bunch of disks, and if this is rotating around, if you look at it head on this way, you see circles, 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 disks, 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 a bunch of disks, all add up to this cone. As you go farther to this way, the circles get smaller, smaller, smaller. The discs get smaller. This way, they get bigger, 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 right? Okay, so we gotta, basically, what do we gotta do for volume? Volume is you integrate the area. Volume is the area times the width, right? You find the area of the disk times the width. That gives you the volume. So we're gonna use integration to do that, okay? But the first thing we gotta do is we gotta get an equation in terms of x for this thing. So what is that thing? It's a line. So we have to find the equation of this line, okay? So we want to find the equation of that line. So do we know a couple points on the line? I think we do. Don't we have point 0, 5 and point 20, 0? So if you've got 2 points, you can get an equation of the line using the, go back to your algebra days, point slope equation of a line. So all we need is 1 point in the slope and plug it in, we can get an equation of the line. So let's see, if this is our x1, y1, x2, y2, right? So how do we find the slope? Let's do that first. Remember, it's change in y over change in x. So what would that be? That'd be 0 minus 5 over 20 minus 0. So what do you get? Minus 5 over 20, which is minus 1/4. And it makes sense because it's the line's going down from left to right, so you should have a negative slope, right? So now we're just going to use our equation, leave y alone, plug y1 in, equals the slope. Leave plain x alone, plug in x1. Right? So what do you get now when you solve for that? I'm flipping my page. I end up getting, if I distribute that and add 5 to both sides, I get y equals minus 1/4 x plus 5. Guess what, guys? That's the equation of the line. Okay, that's our equation of our line. So like I said, a cross section of the cone, though, is going to be a disk that's perpendicular to the x-axis with a particular radius. All these have a particular radius. And the radius is the distance from the x-axis to the line, right? So it's the distance to the line, y equals minus 1/4 x plus 5. X is going from what? 0 to 20. Those are our limits. To find the value, we integrate the area, right, over these disks. So the volume is equal to, we're going to integrate, what's the area of a circle, you guys? Right? Pi r squared. So now let's plug in everything we know. We know x is going from 0 to 20. We know pi is pi. We know r. What is r? R is the distance to that line. It's the line. It's the equation of the line. That's right. That's what that distance is. It's minus 1/4 x plus 5. But don't forget it's squared dx. Okay. So that's what r is. It's the distance to the line. Any particular line. I mean, any particular disk. That's what the r is. Okay. Okay, so now it's just doing the math. Let's see, I'm going to put the pi in front. And I'm going to FOIL minus 1/4 x plus 5. And when I do that, I get 1/16 x squared minus 5 halves x plus 25 dx. Okay? And then I have time to take that antiderivatives, right? So don't forget you got that pi sitting in front. So take the antiderivative of 1/6. You have 1/16 x squared. So it would be 1/16 times 1/3 x cubed, right? Minus 5/2 1/2 x squared plus 25x. And that goes between 0 and 20. Okay? So what do we get? Now we're going to plug the 20 in. You still got the pi, don't forget that. 1/16 times 1/3 is 1/48. 20 cubed minus 5. You multiply the two fractions, you get 5/4. 20 squared plus 25 times 20 minus, oh, thank goodness we can just say 0, because when you plug it 0 in for x, those all go to 0. So what do we end up getting? Whoa, we end up getting pi times 166.667 minus 500 plus 500. So those cancel out, but you got to multiply the pi. So I got 523 point, I don't know how many decimal points they want you to carry it out to, but that's what I got. Okay, so the key here is recognizing that this thing, when it spins around the x-axis, it's going to be a cone. So we had to find the equation of the line in order to integrate it. And we had to realize that we have these disks that were adding up to find the volume of the whole thing. And so how do you find the volumes? The volumes are the area times the thickness of the disk, so that's pi r squared times dx. Plug everything, FOIL everything, and there you go. Whew, I'm out of breath. Okay, I hope that helps, and be careful. There's so many places you can make mistakes. Okay, see ya.